A mere 2,174 years ago, Death Valley was the site of a catastrophic explosion. As, while unknown to many, Death Valley within California, which often ranks among the world's hottest locations, is surprisingly also host to a singular active volcano. This volcano consists of a chain of 14 large and deep explosion craters in the ground, the largest of which measures a whopping half a mile long, 2,450 feet wide, and 722 feet deep. To understand the sheer power of the blast that formed the largest crater of the Ubehebe Craters volcano, I will compare it side by side to that of Sedan Crater. Sedan Crater formed as the result of an underground 104 kiloton nuclear blast in 1962, and yet Ubehebe Crater, which formed due to an explosion at a similar depth, is even larger than that massive aforementioned crater. Today, it is completely safe to visit this volcano as it currently shows no signs of life involving zero hot springs, zero fumaroles, and zero volcanic earthquakes. While the specific cluster of Mars itself is unlikely to ever erupt again, the conditions do exist for a future eruption to occur somewhere within a 6-mile radius of this spot. Such a future eruption would almost certainly also be explosive, meaning it would disrupt regional air traffic and pose the threat of generating up to 10-kilometer-long pyroclastic flows. As a result of this threat and the potential that it could erupt again, Ubehebe Craters is classified as an active volcano and is listed by the U.S. Geological Survey specifically as a moderate threat volcano. If we zoom out from these craters ever so slightly and head just 3 miles to the west, there are a series of highly eroded monogenetic volcanic cones and their associated lava flows. Note how these several million-year-old features seemingly exist along 3 north-to-south trends, which in actuality represent now largely or completely inactive fault lines such as this feature here. And now, going back to the Ubehebe crater, there is also a fault line that extends along the crater's longest orientation, hence the color difference in rock units seen in this image. Both of these features, despite forming millions of years apart, formed due to the same geologic setting which could one day power a similar future eruption. These faults formed due to the intersection of 2 tectonic provinces, the Basin and Range and the Walker Lane. The Walker Lane is a series of faults that accommodates the vast majority of the region's tectonic plate motion not accommodated by the San Andreas Fault. Meanwhile, the Basin and Range represents a broad area where the crust is slowly spreading apart, forming many fault lines. The created fault lines from this motion serve as weak spots in the crust that allow for magma to intrude into the crust on occasion and sometimes produce volcanic eruptions. At Ubehebe, this occurred through the Tin Mountain Fault. In approximately the year 150 BCE, a medium-sized batch of magma intruded into the crust, working its way up the aforementioned fault line and generating a swarm of earthquakes. As gas bubbles in the rising molten rock expanded, it further propelled the basaltic magma upwards, causing it to finally erupt onto the surface in a mildly explosive manner. For the first few days, this slowly built a cinder cone which continued to produce sustained low-altitude ash emissions and strombolian explosions. While this was occurring, shallow magma ran underground to the west, transferring heat to underlying groundwater. This groundwater flashed to steam, causing it to expand in volume by a factor of 1600 until the pressure became so great that it exploded and broke through overlying rock, generating larger ash plumes and multiple several hundred-foot wide mark craters in the ground. As the cinder cone continued growing, the underlying magma dike expanded southwards where there was even more groundwater, causing a series of larger and larger explosions to occur over time. Heavy rainfall subsequently filled one of these craters, causing repeated explosions within it to form the Little Habe Tuff Cone. However, since these explosions blew off the top half of the existing cinder cone which had formed, collapsed material blocked its magma conduit. Magma then spread out laterally underground, causing the largest batch of groundwater so far to flush to steam, build in pressure, and explode upwards with the force of many thousand tons of TNT. As a 14-kilometer high eruption column was blasted high into the atmosphere, Part of the eruption column was so dense that it collapsed back to the ground, generating a series of 200 degrees Celsius pyroclastic flows which scorched the surrounding landscape in all directions, albeit preferentially downslope. This pyroclastic flow would continue running out to 9 kilometers or 5.6 miles away, by which time it had scorched an area of 20 square miles. And this is how the fascinating Ubehebe Craters volcano formed. As a final note, I would like to thank my new patron Judy for supporting this channel.